So topic 11 is which is about air and water, starting with the concept of the water. These are the learning objectives. You should be able to state a chemical test to check the presence of the water and how we can treat the water and then the uses of the water. So what is a chemical test to check the presence of the water? If we want to test, like example, we have a container and it is filled with unknown liquid. We don't know what liquid it is. So we don't know what kind of liquid is this. Say liquid X is there, and we want to test or we want to show like this liquid is a water. So what is the test here? We can use cobalt chloride or anhydrous cobalt chloride. So if we use cobalt chloride or cobalt 2 chloride, which is anhydrous, that is originally blue in color. So anhydrous cobalt chloride, when there is no water present with it, that is blue. But when we transfer this anhydrous cobalt chloride to a container, if there is a water present, then what will happen? It will show a color change and it will turn into pink. So anhydrous cobalt chloride in the presence of the water turn pink. And what is the equation for this reaction? You should know the equation, that we have cobalt chloride COCl2. If water molecules are there like 6H2O, as a result, the reaction is reversible, so it will form COCl2 dot 6H2O. What is the meaning of this dot 6H2O? This water dot 6H2O, it means it is a water of crystallization. What is the concept of water of crystallization? As we know, ionic compounds, when we have ionic compound exists as a lattice, means arrangement of the positive and the negative ion. So this is a lattice of cobalt chloride. So that is COCl2. And this lattice of cobalt chloride is blue in color. But what happened to this lattice if we add water, like example, if we add 6 water molecules to this, as a result, this lattice will turn into pink. And the water molecule which this lattice trapped inside or around it, those water molecules which were outside originally, now the lattice will trap those water molecules inside, and as a result, when it traps the water molecule inside, the color of the lattice will change. So a lattice which traps the water molecules, these water molecules are known as water of crystallization. So here it was blue in color. The cobalt chloride was blue in color, but when we add a water or in the presence of the water, it will turn into pink. So it changes the color in the presence of water. So we can use it to test that the compound which is there can be water or no. If it does not change the color, it means this compound X is not a water. If it changes the color, it means compound X is a water. Also, there is another way to test. The second way, we can use anhydrous copper sulfate, which is originally white in color. So anhydrous copper sulfate, it is white in color. For example, this is a light color, or example, a white color is there. So if we want to test or we want to show that the compound, the substance, the liquid is a water, so how we can show or how we can identify that this liquid here is a water? So when we add this copper sulfate to a container or a liquid, a container which is filled with a liquid, if it changes the color and it turned to be blue. So if this anhydrous copper sulfate, if it turned blue, it become hydrated copper sulfate. So we say that this liquid in which we add this liquid is actually a water. because it only shows a color change in the presence of the water. If there is no water, it won't show a color change. So this is a chemical test and the observation for a water, like how we identify that the compound which is present is a water. Is it clear, this part? The purification of the water, this is how we purify the water. The whole steps are listed here, like the water which we are using for washing or for drinking, how it is purified. So first, because if it's a fresh, it's the water from the source, like example river or lake. So water from the river and the lake, it is passes through the screen. So what is the purpose of the screen? When we pump the water through this screen is like a net. So this screen, it will stop the large particles. So large insoluble particles will not be able to pass through the screen. Very tiny particles or small particles are able to pass through. So water is pumped in and a screen trap any big particle such as twigs, and the lighter small particles, they can pass through this screen. Then the second what we do, that is a coagulant is added. Coagulant means a substance, a compound which can join up the small particle, that's called a coagulant. Normally we use iron 3 sulfate. So we add a coagulant, a chemical, to make a small suspended particle stick together. So when we add iron sulfate here, iron sulfate, what it cause? It cause these particles to stick together, like lighter particle join together or make a cluster here. Then what we do after adding a coagulant to this, the next air is blown through the water in a floating tank to make the coagulant particle float. So what happened, like here the coagulant particles, the lighter particle join together and coagulate. Then from the bottom we blow the air. As a result, when we blow the air at the bottom, from the bottom, so these coagulant will move towards the surface. And when these coagulants move towards the surface, what we can do, we can skim off. Like skim off means like removing the top layer, that's called a skimmed off. So we can remove this top layer and we can make this water purified from these large smaller particles. After aeration or blowing the air, then we use a sand filter. What is a sand filter? A sand filter consists of different layers of the sand. Like example, there are large particles from the top, then there are medium particles in the middle, and there are fine particles there at the bottom. So what we do, we pump the water and this water will flow. So we pump this water, then this water will flow, and using a spray, the water is added or passed through the sand filter. As a result, when we pass through this sand filter, so if even some solid particles are there, like example, still there are fine particles, but some fine particles as they are present, so they will be stopped here, as they can the particles cannot flow through it, only the water find its space to move out. So the water will go out and the particles, the insoluble particles will be left. It may go through the further filtration. For example, we can use a sand or a charcoal to remove a bad taste or a smell. Like, so if we want to remove any smell from the water or bad taste, we can use a sand or a charcoal. Then to kill the bacteria, what we do, we add chlorine. So chlorine is added to kill the bacteria and other microbes. And after addition of the chlorine, we add fluoride compounds to the water because it helps to overcome this tooth decay. So fluoride compounds added to some chemical this water plants to help fight the tooth decay. So when we add then we add fluorine, and after adding a fluorine, the water is pumped to a storage tank where they are storing the water, and then it is supplied to the homes. So this is how we purify the water and we make it drinkable, like we can drink this water. So water from the source like rivers and lakes first screen, then we add coagulant, then we pass air, then passing through the filter of a sand, like different layers of a sand, then using a charcoal to remove any smell, then adding a chlorine to kill bacteria, and then fluoride compounds are added to help fight the tooth decay, and then this water is stored in the reservoir, from where this reservoir it can be supplied to the residential units. So this is how we purify the water and make it drinkable. Then name some uses of the water in industry, like in industry where we use, what are the uses, and as well as in home. So we are using for drinking, heating, plumbing, washing, and in the industry, water is used as a solvent or as a coolant. Like solvent means like many industry, water can be used as a solvent to dissolve different substances, as well as coolant means to remove the heat energy from the system, the water, because it has a higher specific heat capacity, so it can absorb greater amount of heat energy before being boiled, so we can use as a coolant. Like in a car radiator, you will find we are adding a water. There are coolant as well, other coolants, but we can also use water as a coolant. So in the car radiator, when the engine heats up, so water can absorb that heat energy and release to the surrounding. Then water of crystallization. What is the meaning of water of crystallization? So basically, the ionic compounds, the ionic lattice, they trap the water molecules within the lattice, and we call that as a water of crystallization. Like I gave you the example, if we have copper sulfate, so CuSO4 is there, or copper sulfate, which is white in color. So copper sulfate, originally it is white in color. Then what we do, if we add 5 water molecules to this lattice, because this is a regular arrangement of ion, there will be positive and negative ions in the structure. So there will be positive and negative ion. This we called as a lattice. So when we add water molecule, this lattice, what will happen? This lattice will trap the water molecule inside, and these water molecules which are trapped within the lattice, we call them as water of crystallization. Because the substance is a solid state, the state of a substance does not change. It's like not dissolving. Dissolving means we have like lot of water molecules, and the ions separated from each other, so the substance dissolve. But here it's not a dissolving, the ions remain intact, the ions does not change, or the number of the ions does not change. The only thing what happen here, the only thing what happen is these 5 water molecules are trapped, or they're stored within the lattice. So what we call these water molecules which are trapped or stored within the lattice, we call them as water of crystallization. And when some of the compounds, they store the water molecule within the lattice, they change a color, like copper sulfate without the water molecules trapped, that is white in color. But when the same copper sulfate trap the water molecule, this copper sulfate become hydrated copper sulfate, and how we represent? So CuSO4 is a copper sulfate, and then dot 5H2O, it means it traps 5 water molecule, and the color of this copper sulfate is blue. And this water dot 5H2O, this water is known as water of crystallization, means the substance is a crystal form, and it trap the water molecule, refers to water of crystallization. Same thing, it happened with cobalt chloride as well, or cobalt 2 chloride. So cobalt 2 chloride, originally it is blue in color. So we have cobalt 2 chloride, CoCl2. Originally it is blue in color. Now what happened when it trapped, like we add water molecules. Here in cobalt chloride, 6 water molecules are adjusted. So as a result, what we'll see, the regular arrangement of the ion, the lattice will remain there, but that lattice trap the water molecule. As a result, when it trap the water molecule, it also shows a color change. It changes from blue to pink. So these are the ions within the lattice, like positive, negative, positive, negative. So when water molecules are added, so it trap the water molecule, and these water molecules which are trapped within the lattice are known as water of crystallization. So when we write here, it will become COCl2 dot 6H2O, which is pink in color, and originally it was blue. So due to the water of crystallization, some of the compound, not all, but some of the compound, they show a color change as well. So two you have to learn: anhydrous copper sulfate. When it does not have water molecule, we call anhydrous, that is white. But if it get a water molecule, it turn to be blue. Same thing, if we have anhydrous cobalt chloride, it is blue in color. If it absorbs the water molecule, it will turn into pink. We also call them as hygroscopic compounds, the compounds which have a tendency to absorb the moisture or water molecules. Is it clear that the concept of water of crystallization? Then there are two types of agents. One is called a drying agent, another one is dehydrating agent. Drying agent means they can have a tendency to absorb the water molecule from the substance. We call them as a drying agent, such as like sulfuric acid, calcium oxide, calcium chloride, or copper sulfate, or silica gel. Silica gel you will find, like if when you're buying a new set of shoes, it will have a small packet inside, and on that packet it is written silica gel. So what is the purpose of this silica gel? Silica gel absorb the moisture in the box so that the thing will last for a longer period of a time. So when the so what is the difference between the drying agent and dehydrating agent? When substance is used as a drying agent, so substance can be a drying agent or it can be a dehydrating agent. Both cases, both are removing water. Drying agent, it remove water. Dehydrating agent also remove water. But what is the difference here? That how they remove the water? The drying agent is used to remove water from the mixture. Whereas dehydrating agent is used to remove the water from the compound. So if we remove the water from the compound, we call that as the other substance is a drying agent. But if we remove the water from the mixture, like the substances there contain different substances including water, and if we remove the water from that, we call that as a dehydrating agent, a drying agent. So example, we have a moist air. So what is the moist air? The moist air contain nitrogen, because air contain nitrogen, oxygen, carbon dioxide is there, water vapors are also there, H2O, and other inert gases are there, group 8 elements such as helium gas or neon, they are there present, argon is there. So other noble gases are also present. So this is a mixture: nitrogen, oxygen, carbon dioxide, and water. So what we do, example, if I place a silica gel here, a packet of a silica gel or packets of silica gel. So when we place this silica gel and we blow this moist air, or we pass this moist air over this silica gel, so what will happen? The silica gel is a drying agent, means it will trap the water molecule, or it will store the water molecule on the surface. So the packet of the silica gel will absorb the water molecules on the surface, and when we pass this air, this will become a dry air which will contain nitrogen, it will contain oxygen, it will contain carbon dioxide, but it won't contain water because the water is being removed by using a drying agent. So this silica gel is called a drying agent. So whenever, and this moisture is what it is, a mixture. So whenever we remove the water from the mixture, we call that substance which is removing the water or absorbing the water, we call that substance as a drying agent. But what is a dehydrating agent? When we remove the water from the compound, we call that as a dehydrating agent. Like example, we have a glucose which is C6H12O6, like sugar, and we add sulfuric acid here, like we have a sugar crystals, say these are the sugar crystals, and what we do, we add them to sulfuric acid. So this is a sugar crystal which is C6H12O6, and we add this to sulfuric acid H2SO4. What this sulfuric acid will do, it will decompose the sugar into carbon atoms, like 6 carbon atoms, and it will produce 6 water molecules. So by the help of sulfuric acid, this compound breaks down and it gives off water. So whenever we remove the water from the compound, the substance which help us to remove the water from the compound, that substance is known as dehydrating agent. So sulfuric acid is actually a dehydrating agent. When we use sulfuric acid in this reaction, the glucose here or a sugar will decompose and it break down into carbon, and whenever you will see carbon, so there will be a black solid, and because of water molecule, water vapor, so you will observe water vapors as well, or vapors you can also say. So this glucose actually decompose into a black solid in water vapor. So by a chemical reaction, the water is removed from the substance. We call that substance as a dehydrating agent. So here in the first example, in a drying agent, we were having a mixture, and from the mixture the water is removed. But in dehydrating agent, the substance actually chemically break down into water. So that's a main difference between the drying and the dehydrating agents. Is it clear, the concept? So you have to learn some examples related to drying and dehydrating agent. Like example here, the drying agents, like there are various drying agents are there which are used to absorb the water out from like air or a gas mixture, common like concentrated sulfuric acid, calcium oxide is there, anhydrous calcium chloride, and silica gel. And dehydrating agent like drying agent that are so powerful they can remove all the atoms required to make up water. The most common example of a dehydrating agent is a concentrated sulfuric acid as well. Like because it can remove the water molecule from the substance. And hydrated copper sulfate, it can also extract the element of water from a cloth or skin. Like if the substance is like chemically break down the compound and take out the water, we call dehydrating agent. But it only absorb the water, we call that as a drying agent. So this was about the water.